Most people start their morning the same way. Alarm goes off, reach for the phone, make coffee, drink it immediately, try to feel human. The sequence feels logical. The coffee is the functional part. Everything else is just the interval before the coffee starts working. But the sequence has a problem, and it is not the coffee. Coffee is not the issue. The timing is. And there is something available for free outside every window in the world that does more for alertness, mood, energy regulation, and sleep quality than the first cup of coffee, and that most people in the modern world never access because they are inside, looking at a screen when they should be outside. 10 minutes of morning sunlight through your eyes within the first hour of waking activates a biological system that sets the timing of every hormone in your body for the next 24 hours. It starts the clock. Without it, the clock runs imprecisely. Sleep becomes harder, energy is less predictable, mood is less stable, and no amount of coffee compensates for a circadian system that has not been properly synchronized. This is the story of what morning light actually does, why the timing of coffee matters more than most people realize, and why the most powerful tool for optimizing daily energy and sleep quality is completely free and has been available outside your door for as long as your species has existed. The suprachiasmatic nucleus, abbreviated SCN, is a tiny region of the hypothalamus containing approximately 20,000 neurons. It is the master clock of the human body. Every cell in the human body has its own internal clock, genes that cycle on and off on approximately a 24-hour rhythm, regulating the timing of cellular processes including metabolism, protein synthesis, DNA repair, and immune function. But individual cellular clocks drift slightly from true 24 hours if they are not regularly synchronized. The SCN is the master synchronizer. It receives light information directly from the retina and uses it to keep all the body's cellular clocks aligned with the external light-dark cycle. The specific cells in the retina that communicate with the SCN are not the rod and cone cells responsible for vision. They are a third type of retinal cell called intrinsically photosensitive retinal ganglion cells, IPRGCs. These cells contain a photopigment called melanopsin that is most sensitive to short wavelength blue light in the range of 480 nanometers, the wavelength that predominates in natural daylight, particularly in the morning. When morning light activates the IPRGCs, they send signals directly to the SCN through the retino-hypothalamic tract. The SCN receives this signal as confirmation that it is morning, that the light-dark cycle has reset, and uses it to synchronize the timing of every hormone, every cellular process, and every physiological rhythm in the body. This synchronization is not a passive background process. It is the foundation upon which every aspect of daily biological function is built. The first and most immediate consequence of SCN activation by morning light is the timing of the cortisol awakening response. Cortisol follows a precise daily rhythm. In a well-entrained circadian system, cortisol begins rising approximately 1 hour before waking and peaks within 30 to 45 minutes after waking in what is called the cortisol awakening response, CAR. This peak is not pathological, it is functional. It is the body's primary mechanism for transitioning from sleep to wakefulness, providing the metabolic fuel, the immune activation, the cognitive arousal, and the physical readiness that morning activity requires. The cortisol awakening response is the body's natural energy drink. It provides a surge of biological activation that, in a properly functioning circadian system, produces genuine alertness without the jitteriness, the crash, or the adenosine rebound of caffeine. Morning light amplifies and sharpens this cortisol peak. Research published in the Journal of Biological Rhythms found that morning bright light exposure significantly increased the magnitude of the cortisol awakening response compared to dim light conditions, producing a larger and more effective natural cortisol peak that improves mood, alertness, and cognitive performance in the hours that follow. Here is where the coffee timing problem becomes relevant. Caffeine works by blocking adenosine receptors in the brain. Adenosine is the molecule that accumulates during waking hours and creates the sensation of sleepiness, the sleep pressure that builds throughout the day. Caffeine occupies the receptors that adenosine would bind to, preventing the sleepiness signal from reaching the brain. This is effective at producing alertness, but caffeine consumed during the cortisol awakening response, in the first hour after waking, when cortisol is naturally at its highest, has a different effect than caffeine consumed 2 hours after waking, when cortisol has begun to decline. When cortisol is high and caffeine is introduced, the body detects a sustained state of elevated arousal and begins downregulating its sensitivity to cortisol. cortisol receptors become less responsive. The natural morning cortisol peak becomes less effective. Over time, people who habitually drink coffee immediately upon waking develop a reduced natural cortisol awakening response, meaning they become more dependent on the caffeine to achieve the morning alertness that the cortisol was supposed to provide for free. This is why habitual early morning coffee drinkers often report that coffee stops working or that they need more of it over time. They have trained their biology to reduce its own natural alertness mechanism by consistently replacing it with caffeine during its peak activation window. The research-supported recommendation is to delay the first coffee by 90 to 120 minutes after waking, allowing the cortisol awakening response to complete its natural arc, providing the morning alertness that it was designed to provide, and consuming caffeine as a supplement to declining cortisol rather than a replacement for it during its peak. The serotonin and melatonin relationship is the second mechanism through which morning light governs not just the morning, but the entire day and night. Serotonin is a neurotransmitter produced primarily in the Raphe nuclei of the brainstem, with additional production in the gut. It plays central roles in mood regulation, social behavior, appetite, and cognitive function. Its production is stimulated by light, specifically by the bright light of daytime that activates the retinal photoreceptors and downstream neural pathways that drive Raphe nuclei activity. Morning light exposure triggers serotonin synthesis that begins within minutes of light contact with the eyes. The more bright light exposure in the morning, the more serotonin is produced in the hours that follow. This serotonin elevation contributes directly to the mood improvement, the motivation, the reduction in anxiety, and the social engagement that people who regularly spend time outdoors in the morning consistently report. But serotonin's role in sleep quality is even more significant than its daytime mood effects, because serotonin is the precursor to melatonin. Melatonin is synthesized in the pineal gland through a multi-step process that begins with serotonin. Serotonin is converted to melatonin through a series of enzymatic reactions that are activated by darkness and suppressed by light. When the light-dark cycle triggers the shift from light to darkness in the evening, serotonin is converted to melatonin, which rises to signal the body that nighttime has begun and sleep should follow. The amount of melatonin the pineal gland can produce in the evening is directly limited by the amount of serotonin available as a substrate. More serotonin produced during the day, through morning light exposure, means more melatonin available in the evening. Better melatonin signal. Faster sleep onset. More consolidated sleep architecture. Better sleep quality. People who spend time outdoors in the morning and receive adequate light exposure consistently show earlier and higher melatonin peaks in the evening compared to people who remain indoors throughout the day. This earlier, higher melatonin peak corresponds to faster sleep onset, more consolidated nighttime sleep, and better morning alertness the following day, creating a positive feedback loop in which morning light improves both daytime function and nighttime sleep. The practical comparison between morning light and artificial indoor light is important to understand because most people assume that turning on lights in the morning accomplishes the same thing as going outside. It does not. Light intensity is measured in lux. A well-lit indoor office typically provides 300 to 500 lux. A cloudy outdoor environment in the morning provides 10,000 to 20,000 lux. A bright sunny morning can provide 100,000 lux or more. The IPRGC photoreceptors that communicate with the SCN require sufficient light intensity to produce a robust circadian synchronization signal. At indoor light levels, even bright indoor environments, the signal is significantly weaker than what outdoor morning light provides. The circadian clock is set less precisely. The cortisol awakening response is smaller. The serotonin synthesis is reduced. The melatonin conversion in the evening is correspondingly reduced. This is why the research on morning light exposure and sleep quality, mood, and circadian alignment consistently specifies outdoor light rather than indoor light. The mechanism is the same, but the intensity required to drive it robustly is only reliably achieved outdoors. On overcast days, outdoor light intensity still significantly exceeds indoor lighting. A heavily overcast sky typically provides 10,000 lux or more, compared to the 500 lux of a bright indoor office. Going outside on a cloudy morning still produces significantly more circadian benefit than remaining indoors, even though it does not feel as bright. The minimum effective dose, according to the research, is approximately 10 minutes of outdoor light exposure within the first hour of waking, Without sunglasses that filter the wavelengths the IPRGCs respond to most strongly. Wearing prescription lenses or contact lenses is fine. These do not filter the relevant wavelengths significantly. Looking directly at the sun is not necessary and not recommended. The goal is ambient outdoor light through the eyes, not direct sun exposure. The seasonal and latitude considerations are worth understanding because they affect how much light is available and what adjustments may be necessary. At higher latitudes during winter months, the sun rises later and the morning light intensity is lower than at temperate latitudes during summer. For people living at latitudes above approximately 45 degrees in winter, most of Northern Europe, Canada, and Northern United States, morning outdoor light exposure at the optimal time may not produce the same light intensity as it would at lower latitudes or in summer. In these contexts, a SAD lamp, a bright light therapy lamp producing 10,000 lux, used for 20 to 30 minutes within the first hour of waking, provides a meaningful substitute. The IPRGC response to artificial light at 10,000 lux is similar to the response to outdoor morning light at similar intensity. Research on SAD lamps consistently shows improvements in mood, energy, sleep quality, and circadian alignment comparable to those achieved through outdoor morning light exposure. The lamp is not a perfect substitute. Outdoor light has a spectral quality and angular distribution that indoor lamps do not fully replicate, but it is substantially more effective than no light exposure, and the research on its benefits for mood and circadian function is well established. Here is the practical implementation that captures the documented benefits. Within the first hour of waking, as close to immediately after waking as is practical, go outside for 10 minutes. Walk, stand, sit on a step. The activity does not matter. The light exposure does. Face toward the direction of the sun or open sky without looking directly at the sun. No sunglasses. If you wear prescription glasses or contact lenses, keep them. Delay coffee for 90 to 120 minutes after waking. Allow the cortisol awakening response to complete its natural arc. The alertness you feel during this window is real and biologically produced. It does not require caffeine to occur, and caffeine consumed during it may gradually reduce it through receptor downregulation. The first coffee, consumed after the cortisol peak has begun to decline, works with the biology rather than displacing it. Repeat the morning light exposure daily. The circadian benefits are cumulative, and they are also lost with inconsistency. A circadian system synchronized by daily morning light exposure produces predictable, stable energy and mood throughout the day and reliable sleep timing at night. A circadian system receiving irregular or insufficient morning light synchronization produces the irregular energy, the afternoon crashes, the difficulty sleeping at consistent times, and the general sense of being slightly off schedule that many people experience as normal, but that is actually a correctable circadian drift. Here is the honest framing. The morning coffee ritual is not the enemy. Caffeine is a useful compound with well-documented cognitive effects, and the ritual itself has behavioral and psychological value that is separate from the pharmacology. The problem is the sequence. Coffee as the first biological input of the morning, consumed during the window when the body's own natural alertness mechanism is most active. Morning light is not a wellness practice or a biohacking protocol. It is the synchronization signal that the human circadian system evolved over hundreds of thousands of years to receive at the beginning of every day. The indoor lifestyle of modern work has created, for the first time in human history, a population that regularly begins the day without receiving the signal that its biology was designed to need. 10 minutes. Outside. Within the first hour. No sunglasses. The coffee can wait 90 minutes. The circadian system cannot. It needs the light signal now at the start of the day to set the timing of everything that follows. If this changed how you think about your morning routine, hit the like button. Share it with someone who reaches for their phone before they reach for daylight,